Once again, good afternoon and welcome to our Mathematics of Investment class. Now we are done with lesson 1 on simple interest and discount. Lesson 2 is about compound interest. And now we'll start with lesson number 3. It's about simple ordinary annuity. Our memory verse for today is found in Proverbs 21 verse 20. It says, "The wise store up choice food and olive oil, but fools gulp theirs down." Our memory verse today reminds us to save wisely and not to spend much. You see, for our classes, we keep on talking about investment, interest, and annuities. So we need to use our money wisely. In your mole, you can find the topic for simple annuities. And we have until March 8th to complete this. Now we'll talk about ordinary annuities. In this lesson, we'll find the present value and amount at the end of the term. Then find the term of the ordinary annuity. And at the end of today's session, you'll be able to define ordinary annuity, its present value and compound amount, derive formulas for the present value and compound amount of an ordinary annuity, and solve annuity problems where either present value, amount or future value, term or interest is unknown. Now let's start. Now, what is an annuity? And how is this different with the simple and the compound interest that we have learned in the few meetings? Now, an annuity is a series of equal payments. Remember, there are equal payments and there is a regular interval and with a fixed interest rate. Actually, there are 3 requirements for an annuity. Number 1, equal payments. Number 2, regular intervals or payment interval. And number 3, fixed interest rate. Now, how is annuity different to simple and compound interests? In simple and compound interest, it is just a one-time payment. Or, for example, you have made a loan, then after 3 years, you will pay that loan. Or you have made a loan with home credit. You can have one payment, how much, then restructure it and have another payment. In simple and compound interest, we are making the thought of one-time payment. But in annuity, this is related to the concept of installment. Now, like for example, you went for a home credit loan and then you have equal payments. You pay 500 every month. That's the regular interval with a specific interest rate. So in annuity, we make series of installments and that makes it an annuity. Now, the annuity can be classified based on payment terms, payment schedule, interest period, and payment interval. Let's first have the classification based on term. Now, the first one is contingent annuities. If you say contingent annuities, there's no specific number of payments, but it depends on a certain time period. For example, insurances. You keep on paying insurances and then the payment ends at the time of your death. Or another, we have now PhilHealth contributions. We keep on paying PhilHealth contributions till the time that you want to avail of the PhilHealth benefits. The same with the SSS, with the GSIS. It ends upon your retirement. So these are contingent annuities. The second is the annuity certain, based on the word certain. It means that there is a certain beginning and ending amount, a date. For example, Globe Telecom bill, postpaid. It is usually renewed every 2 years. So it is an annuity certain, for you know that you'll pay from this month of the year, example, from August 2020 up to August 2022. So there is a beginning and an end to your payment. So we call that annuity certain. The other is perpetuity. In perpetuity, it's an annuity in which the periodic payments, there is a beginning on a fixed date and it continues indefinitely. For example, the very common this time, it's non-redeemable. The very common investment schemes that we have this time. As long as you want to benefit on that, then you need to pay. So that is a perpetuity. Or another, a scholarship. I'm not sure with your Unifast because I heard that it's an annuity certain up to 4 years only. But for some scholarships, they give you as long as you are studying. So that is under a perpetuity. Now, another classification is based on the payment schedule. For example, let me just underline the keywords here. For ordinary annuity, the payment is done or received at the end of the term or of the payment interval. For example, you made a loan and then you don't pay at the starting. You pay at the end. For example, if you pay every month, you pay at the end of the month. In annuity due, you start paying at the beginning of the time period. Let's not confuse this with advance payments, because sometimes we thought that monthly house rentals are annuity dues, because at the start of the rental, you will pay for that month. So when the payment is done at the beginning of the time period or the payment interval, we call it an annuity due. Another is deferred annuity. In deferred annuity, our keyword is delayed or deferred. This is a type of annuity in which the first payment is delayed or deferred. For example, if your parents or you have tried the SSS and the Pag-ibig loans, these are deferred annuities. Because for example, you make a loan in October, sometimes they do not ask payment by October at the start or at the end of October. Usually, they delay the first payment and they'll say you'll pay starting January. Here, there is a delay or a deferment of the first payment. So we call this a deferred annuity. Again, if the payment is given at the end, that's ordinary annuity. At the beginning, we call it annuity due. And if there's a delay in the first payment, only in the first payment, we call it a deferred annuity. The next classification is based on the interest period and payment interval. For simple annuity, the compound periods is equal to the number of annuity payments in a year. For example, it's compounded monthly, and then you also pay every month. The compounding period and the payment interval are equal. Therefore, it's called a simple annuity. But if the compounding period is not equal to the number of annuity payments in a year, then we call it a general annuity or complex annuity. Example, the loan is compounded monthly. but you will pay once a year. The compounding period and the payment interval are not the same. So it is called a general annuity. Now for this class, for this lesson, we'll be talking about simple ordinary annuity. So based on the description, on the definition, it's a simple annuity because the compound periods are equal to the number of annuities per year, and it's an ordinary annuity. The payment is done or received at the end of the payment interval. Let's have more terms to remember for this class. First term is the payment interval or payment period. It talks us how often will you pay every month. Then that monthly is what we call payment interval or payment period. Next, term of annuity is how long will you pay. For example, with Globe Telecom bill, you'll pay for 2 years. That 2 years is called the term of annuity. How much will you pay? I'll pay $999 for my Globe Telecom bill. So that $999 is called periodic rent, or in some books, it's called payment, periodic payment, or regular payment. The next one is the future value of an annuity. For example, I keep on saving 100 pesos per month for 5 years with an interest rate, okay? So that amount that I will have at the end of 5 years, it's called future value. The present value, present tense, it's how much should I give this time in order to get this amount every period. By the way, annuity is not only for loans. Annuity is any installment that you receive. For example, if it's an installment for a loan, it's annuity. In your Unifast, you only you only receive that once a semester. But if you have tried the SHED and the DOST scholarship, they are giving you 7,000 to 10,000 per month. If you go for master's or PhD, they will give you 33,000 per month. That 33,000 per month, or the installment per month, is still called annuity. Or once you will retire, you will receive monthly pensions, and that's an installment, right? So it's still called an annuity. Now the present value talks about how much should I give today for me to receive this much in the near future. That amount that you will receive today is called, that you need to save today, is called the present value of an annuity. The future value, how much will I receive at the end of the term? Any questions with the terms before we go further?
No more, ma'am.
Okay, thank you. Now let's go. Wait first. Here. This is the time diagram for an end payment ordinary annuity. Now, if you see, this is an ordinary annuity. Why? In the zero, that's the time when you made the loan, or the moment that you made an agreement. And then at the end of the first period, you will make a payment. In the next period, you will make another payment. This is an ordinary annuity, because if this is an annuity due, you need to start your payment at zero. It means that the moment you started with a loan, or the moment you started with the rent, you need to pay at the beginning. Now, I keep on telling you in the past lessons that I only wanted to have one formula per, per topic. But let me make this straight with you. In annuities, the formulas are so long. I'm not sure because you see, we don't have math of investment before in college. So I'm not sure of the extent that they will have this in the board examination. But you need to get to familiarize with the formulas. Here are some symbols to remember. S of n means future value. A of n means the present value. R is the size of each annuity payment. Or I'm asking you, how much are you paying per term, per period? That's your R. J, remember last time, it's the nominal interest rate. M is a number of conversion per year. So for example, if it's compounded quarterly, then our M is equal to 4. T is a time period or term of the loan or investment. It's in years. N is a total number of payments. How will you do it? You multiply the number of conversion periods times the number of years. I is our interest rate or the periodic interest rate. That will be the nominal interest rate divided by the number of compounding periods in a year. Now let's start. Let me share with you the formula for simple ordinary annuity. The first formula is for finding the future value of the simple ordinary annuity. The next formula is this, the formula for the present value. How is it different? If you see, if it's a present value, our exponent will become negative n. And if in future value it's -1, in the present value it's 1 minus. Then, based from these two formulas, you can derive the next two formulas. Let me show you that once you get into the topic. Now let's start. Problem number 1. Cecilia Antonis has been contributing, has been contributing 460 pesos. That's our R, periodic payment, at the end of each quarter. For the past 18 quarters to a savings plan that earns 9% compounded quarterly. What amount will she accumulate if she continues with the plan for another year? Now, here's what you need to remember. You need to check first, because in this lesson, we'll just be talking all about simple ordinary annuities. But in my general mathematics class, I mixed all from simple ordinary annuity to simple annuity due to general ordinary annuity to general annuity due. So there are 4 types. So you need to check first. When is the payment made? Every quarter. The compounding period, it's quarterly. So this is a simple annuity because they are the same. When was the payment done? The payment was done at the end of, at the end of each quarter. So it is a simple ordinary annuity. Our R here is 460. Now our J is 9%. It's compounded quarterly, so our M is 4. Now what is our I? What is our periodic interest rate? Anyone? What's our periodic interest rate?
0.0225, ma'am.
Very good. That's 0.099% divided by 4. So our I is 0.0225. Now, we need to check our N. Our N is a total number of paying periods, right? It's for 18 quarters, and then you will add it for another year. So it means that 18 plus 4. No need to have for the M and the T because the T is not given. So just go directly to N. So it means you're paying for 22 quarters. The question is, what amount will she accumulate if she continues with the plan for another year? It means that the person is saving, and then how much will be? That is a future tense, right? So we're looking for the future amount, the future value of the simple ordinary annuity. We're looking for S of N. It's going to be R times 1 plus I to the power of N minus 1 over I. That will be 460 times, 1 plus 0.0225 to the power of 22 minus 1 over 0.0225. What is our answer? Wait first. Let me share another. Can you see my calculator? No. What happened? Can you see my calculator here?
Yes, ma'am.
Okay. This is as an example of a 4-line calculator. I'm telling you, when you press A over B, it will give you the fraction. So we have 460 times. That will be 1 plus 0.0225 to the power of N. 22 minus 1 all over 0.0225. There's the answer. The answer is 12,911.12 pesos. Any questions? No other questions? Let me go back to our form. This one. Let's go to problem number 2. Now in problem number 2, wait first. I have the slideshow. Sorry. Okay, let us have problem number 2. Marlon de la Cuesta spends 850 per month. Now, what is that 850?
R, ma'am.
Okay, very good. That is your R. Per month, okay? On cigarettes. If he stops smoking and invests the same amount in a plan paying 15%, what is this? What's 15%?
J, ma'am.
J. Compounded monthly. So what will be our M?
12.
12. Very good. How much will he have after 4 years? What is that for?
Time.
Time. Very good. So what will be our periodic interest rate? What's our I?
$0.0125.
Okay, 0.15 divided by 12. So 0.0125. Very good. Next, what will be our N? The total number of payments. What's our N?
48.
48, ma'am.
Very good. That's 4 times 12. 48.
Ma'am,
No.
na ko question, ma'am.
Yes.
Ato ganina bitaw, ma'am, kung dili na yatag ang time, ma'am, kato i-kuan na lang namo tong para ganina imong gibuhat tong gi-add na dito.
Yes, because remember, N is telling us how many payments are there in all. Diba? In the previous, let me go to the previous. In the previous problem, wait. In the previous problem, it says you've been paying for 18 quarters and you'll pay for another year. So we ask for N. How many payments are there? 18 plus 4, 22, right? But for this problem, you need to ask again, how many payments will there be in all? So you need to multiply. There are 4 years and 12 payments in a year. So there will be 48 payments. Am I already clear?
Okay, ma'am.
Okay. So now we're asking, what are we asking in the problem? How much will he have? Right? What's the tense? It's an English class. What's the tense? Future tense, present tense. It's a future tense, right? Will. How much will he have? So it means that we're looking for the future value, still S of N. You start memorizing R times 1 plus I to the power of N minus 1 over I. For present, you subtract it from 1. Okay, so we solve. That's 850 times 1 plus 0.0125. Sorry, I'm not using the proper, this should be like this. To the power of 48 over 0.0125 minus 1 on top. Okay, what's the answer? What will be the future value? What's the future value?
$55,444.13.
Very good. That is now the answer. You know what's my favorite? My favorite is the practical application of the problem. What's the application of the problem? You start saving now. And they say that once you start saving, you need to invest it, not in your piggy banks, but in something, somewhere where there will be an interest rate. They say, I have read something in the problem. It's about Mr. Marlon de la Cuesta quitting smoking and starting to invest. They said that in another book that I read, how to save wisely and to have a fit body. They say no more eating between meals. Instead, the money for your snacks, you invest it somewhere, and then you'll realize it will be a very good investment. It's hitting two birds. You don't eat between meals, plus you're investing at the same time. Now, let us go to the next type of problem. In the next type of problem, we'll be talking about the second formula. Remember, what is A sub N? Again, what is A sub N?
Present value.
It's the present value. It's asking you how much should you invest today. Now let us start. Determine the present value on July 7 of 6,800. What is this one? Sorry. What is that 6,800?
R, ma'am.
R. Paid at the end of each subsequent calendar quarter for 7 years. This is our time. Money over 6%. That's our J. Compounded quarterly. So what is our M?
4.
4. Very good. Now we ask, what will be our periodic interest rate? Our periodic
0.015.
Yes, 0.06 divided by 4. So 0.
0.015.
Very good. Next, what is our N? How many payments are there?
28.
28.
7 years times 4 times in a year. So 28 payments. That's our N. We're looking for the present value. So it's A sub N. We start memorizing the formula. That's 1 minus 1 plus I. It's a present value. So our exponent is negative N over I. So there's R outside. Our R is 6,800 times 1 plus 0.015 to the power of negative 28 over 0.015. What's the answer? What's the present value? What's our present value? Any answers for the present value? Let me use my calculator here. Hope you can see my calculator. That's 6,800 times, ABC. 1 minus 1 plus 0.015 to the power of negative 28 all over 0.01. There. That's the answer. Hope you are checking it with your answer. The answer is 154,541.67 pesos. Any questions?
None so far, ma'am.